Let's consider a non-uniform probability space. So same deal as before, same sample space, but now one of the sides of our dice is weighted in such a way that it comes up 5/8 of the time, in particular, the 1. So let's think about what this probability function will do with each of the different sample points. Now for just the moment, I just want you to use your intuition, and then I'll give you a somewhat more rigorous treatment in a moment. So the first question is, what's the chance that the dice come up 1-1? So I think a good intuitive answer is, well, there's a 5/8 chance you get a 1, and then another 5/8 chance you get another 1, so 25/64. Now, if you didn't feel comfortable with that, I'll show you a picture in a moment. But just pattern matching, let's think about these 6 outcomes. What's special about them? Well, they all have 1-1 and 1 something else. So what's the probability there? Well, it's going to be 1/8 times 5/8, or 5/64. And lastly, we have the other 9 outcomes, which are all just 1/64 chance, or 1/8 times 1/8. Oh. Well, how do I know that? Maybe you have some intuition for it. An argument you can make for this is to think about the set of outcomes as what I'll call here a tree diagram. So I have a start point here, right there for you. And that point is where we start before we roll any dice. If we roll a die once, we could get a 1 with chance 5/8, a 2 with chance 1/8, a 3 with chance 1/8, or a 4 with chance 1/8. Okay. Now it's not the whole experiment. We have to roll another die. So let's suppose that we rolled a 1. What could happen? Well, there's a 5/8 chance that we got a 1 again. So what's the chance that that happened? Well, there's a 5/8 chance that you got here. And then after that happened, now among the things that could happen to you, there's a 5/8 chance you get a 1 again, or 25/64. Then we have these 3 outcomes, which is, well, you got a 5/8 chance of landing on the 1. And then among the possibilities that could happen, you had a 1/8 chance of getting a 2, a 3, or a 4. So we multiply these together and we get 5/64. Now hidden in between the lines here is I've made assumptions about independence, right? I was assuming that the 2 dice rolls, it doesn't matter what you rolled the first time, what you get the second time. And we'll talk a little bit more about this in a future lecture. But for today, just going to say, I kind of swept that under the rug. They need to be independent. Okay. What about the other possible outcomes? Well, we have these other 6 or 12 outcomes. And the same argument holds there. You can see all of the nodes in orange are the case where we had 1-1 and 1 something else. And those are all 5/64 because they were the product of a 1/8 and a 5/8. Okay. Now this is basically the same argument I gave out loud before, but maybe this visual picture helps be more convincing. Okay. So let's think about events in a non-uniform probability space. What happens there? Well, a question we might ask ourselves is the same one. What's the chance the second is greater? And one thing I'll mention is that when I watch videos about math, like it's some random person on YouTube talking, or a lecture video I'm watching, I like to actually pause and do the problem. So if you're watching this online, which you must be because you're watching, I encourage you to try and work it out. Okay. So in this particular case, it's the same 6 outcomes as before. We just add up their probabilities. There's 3 which are probability 5/64, and 3 which are probability 1/64, giving you a total probability of 9/32.